Hello everyone, Lucky Arduino here. Today I'm going to be showcasing a short and easy warning system project using three colored LEDs, green, yellow, and red, and an active buzzer and a potentiometer. Let's get into it. Alright, so the first part that we have here is our active buzzer with the little white covering on top, and you know this is an active buzzer because there's nothing on the bottom, it's just a black cover. Whereas you have the passive buzzer with a little blue covering, and you have no white covering on the top. And the difference between these two is that the active buzzer produces a set tone using a voltage of any sort. So the voltage can be any level and it will still produce the same sound just at different volumes. Then you have the passive buzzer where you need to connect it to AC voltage, so one of the A ports on your Arduino, so that it can deliver varied voltage which produces different sounds, different notes on your passive buzzer. And so this is important. If you check out my Christmas songs video, you'll see that I use the passive buzzer, but in this project I'm going to be using the active buzzer because we don't need multiple tones. We only need one set voltage tone as an alarm. Alright, so here we have a potentiometer, and this essentially acts as a dial. It has wide ranges of applications in everyday life, such as volume controls in your car, right? Most likely those still have a dial. And how we've done this is we connected 5 volts and ground to one side of the potentiometer, and you have an analog port on the other side to read values between 0 and 1023. And this is super useful because it allows you to change values. It's called variable resistance during your project, not just before or after, right? And this is especially useful in a warning system project such as this one because it allows you to change the values of where something is reaching a threshold. Or you can program it that way, or you can say that when it reaches a certain value, something happens, right? And that's why they're super useful in everyday life and in this project. All right, let's see how this project works. So first, this potentiometer's value is at 0, and the LED lit up is green. And once we reach a certain value, oh, it's yellow, right? And the potentiometer is turned, and then we turn it a little bit more, and we reach red, and the buzzer turns on. And we can control this anytime. We can actually bring it up and down, right? And so what this is supposed to simulate is like you're turning a dial and you're not supposed to go past a certain point, but it's warning you before you do, and your potentiometer breaks, right? So one downside to potentiometers is that if you overturn them, you actually end up breaking them really easily. And that's the only downside to using them with Arduino. As well as it's really easy to lose because you can just take off the top of it and put it back on, right? So this part is very easy to lose, and sometimes it glitches out as well. But other than that, it's a really useful component, and it's pretty well implemented in Arduino, but it is more efficient in more real life and industrial applications as well. And so let's take a quick look at the code for this project. All right, let's take a quick look at this code. So first we have the 3 ports, red, yellow, and green for the LEDs. Then we have the buzz pin for turning on the buzzer. Then we have the potentiometer pin that is A0 that detects the values coming in from the potentiometer. And then you have the P-val, which is that value read by the P-pin. So then all of these are output except for P-pin, which is input, because you need to read the values coming from the potentiometer. You also start the serial monitor, which you can see on the left. And so first what we do is we assign P-val this value coming from the pin, which is you use this command called analog read, and that will convert it into an integer value that we can use, or float value. Then we read if P-val is greater than or equal to 750. So remember that the values of the potentiometer go from 0 to 1023. And so this is saying that if it's above 750, meaning pretty much all the way to the right, then the buzzer will turn on, the red will turn on, yellow and green will be off. Just to have another safeguard, I read the pin again, and then I print the val to the monitor, and we delay. So it keeps checking over and over and over until it's not greater than equal to 750. And so here we have, if it's less than 750 and it's greater than equal to 300, the buzzer will turn off, red will turn off, yellow will turn on, and green will turn off. Then we do the same process, reading and printing the value. Then we have if preval is less than 300, which is when it's green is high and the rest are low, meaning they're all off. And then we do the same thing, we read the value and we convert it into a monitor value. So you see off screen, I'm going to turn the potentiometer and you can see the values start to go up. And at this point, we see yellow turn on, and now we have red turning on. And you can hear the volume off to the side. And so this type of system is really useful for like precision manufacturing and like parts systems where you need to be below a certain tolerance, and if you go over that tolerance, then it'll send you a warning message of some kind, maybe a display on your screen or a sound to let you know. This is just the most basic version, a sound, but if it's possible to also hook up an LCD screen that tells you that there's a warning here while also playing a sound. And so there's a lot of applications, and there's a lot of things that you can build upon with this project, and these are just the basics, but it's a good starting point to build more intricate and elaborate projects about alarm systems and the applications and uses for those. Thank you so much for watching this video. If you liked it, please subscribe and like the video. Also, don't forget to check out my website, which will be on your screen right now, www.luckyarduino.weebly.com, and this will give you information on all my projects and tutorials in an organized manner. Don't forget to also check out my tutorials page, where I'll be going into more in-depth descriptions of these components that I use in all my projects. And once again, thank you so much, and see you in the next one.